Alright. 9. Alright, let's start with 2. Let's work our way up. Got calculators ready? Alright, you have a piece of office equipment valued at $25,000. That's the starting value. So that means that is your principal. Okay? P is equal to $25,000. It depreciates at a steady rate of 10%. So the rate is 10%, okay, but it's going down, so you're going to have to, the change is negative. Okay, you got to account for that. Alright, it says in how many years will it be worth $5,000? So that means the amount it's going to end up is $5,000, and they want you to find T in PERT. So A is equal to PERT is the problem, and right now you know 5,000 for the A, and you know P happens to be 25,000. Okay, and then E, and convert that into a decimal, that would be negative 0.1 T. So when you divide, those 3 zeros are going to cancel. 5 over 25 is equal to E to the negative 0.1 T. Okay, now how do I bring this T value down? ln both sides. Very good. ln of 5 over 25 is equal to, when ln the right side, I am going to get negative 0.1 T. My T is equal to ln of 5 over 25 divided by negative 0.1. Okay. This is in terms of, it doesn't say years or months, so I can leave it like that. Does it say years? How many years? Okay. Years. I'll take that. AP takes that. Unless they tell you to round to the nearest, you know, so and so. Then you have to actually calculate it. Alright. So that's 2. Let's go to 3. A strain of bacteria can grow from 30 to 195 in 5 hours. Okay, starting at 30, so that's going to be my C. That's going to be 30. It's going to grow to 195 in 5 hours, so that means my Y is going to be 195. The time is going to be 5 hours. Okay, the question is find the growth constant. They want you to find K. Okay, find K. So we're going to use Y is equal to C E K T. Same as PERT. Okay, we're not talking about interest anymore. Yes. T? Time? Alright, we're going to plug in everything we know. My Y is 195. That's what I end up with. I start with 30. Okay, and I have an E to the KT. So T is 5, so 5T. So I'm going to divide both sides by 30. I get 195 over 30 is equal to, okay, E 5T. What do you think I'm going to do to both sides? Solve for T now? ln. So ln of 195 over 30 is equal to 5T. And what's my, oh, well, 5K. 5K. K, sorry. K. 5K. So my K turns out to be ln of 195 over 30. Divide that by 5. And if they give me in terms of hours, I'm going to put hour. Oh no, K doesn't have, this is not time, so I'm done. So if you want to convert that into a decimal, calculate that, that's fine. Or you can leave it like that. Joy. They're both the same. This is when you first start out in PreCalculus, you start out with PERT because we're talking about continuous rate, interest, and whatnot. Okay, but that's what you basically use. That's for everything else. It's the same formula. Yes, sir. I will ask you to do that when you get to calculus. Okay, I will say answer the question. Okay, you should, if you were in calculus, I would say, you would say the growth constant is k is equal to blah blah blah. Okay? Yes. The y is what you end up with. That's the function. Okay? The principal is what you start out with. That's my initial value. That's my c. Okay? And the r is the rate, interest, but we call that growth constant right there. And obviously t is for time. Yeah. Yeah. Number 4. Okay. Alright. Remember which ones you want. 9, 11, 12. Number 4. Alright, number 4. You have a substance that decomposes very actively. Its half-life is 32 years. Find the decay constant. Alright. Y is equal to C E K T. Okay. And it says half-life is 30 years. All they tell you is T is equal to 30 or 32 years. 32 years. Okay. And they want you to find K. Okay. All this means is this. If you start out with C, in 32 years, you're going to have half as much. So C over 2 is equal to C, okay, E, 32K. Divide both sides by C. 1/2 is equal to E to the 32K. ln of 1/2 is equal to 32K. And so my K is equal to ln of 1/2 over 32. That's all half-life means. Whatever you start out with, you're going to have half as much left. Well, alright, number 9. I did number 9. Killing me. It's in the notes. Did you take notes? 8. 8. Alright. A bacteria will grow from 200 to 3200, so this means my C is equal to 200. Okay, my Y is 3200. That's my end. Okay, and it takes 120 minutes, so T is equal to 120 minutes. Okay, always be careful when they give you units, that sometimes they give you some things in terms of minutes, and sometimes they give you other things in the same problem in terms of hours. So you have to stay consistent and convert things. We don't have to worry about it in this problem. Find the growth constant of the bacteria. Okay, if time is measured in hours, there we go. We do have to worry about it. Okay. This is going to be 2 hours. That's why we have to do the conversion now. Okay. And then find the number of bacteria that you have in 3 hours. Okay. First of all, you got to find K. And after we find K, we've got to find out what will happen in 3 hours. Alright. So you start out with 200 cells, and you find out 2 hours later it's 3,200 cells. Okay. Well, how much, if the rate of change continues in that fashion, well, how much will you have in 3 hours? Okay, you've got to find that constant. Okay, so we're going to go Y is equal to, okay, C E K T. So plug in everything we have. That's 3,200 is equal to 200, okay, E, and then 2K. Of course, the 2 zeros cancel out. The 2 will reduce 32 to 16 is equal to E to the 2K. We're going to ln both sides. So ln of 16 is equal to 2K. And my K is equal to ln of 16 over 2. That is my growth constant. So my function now, my mathematical model looks like this. 200 e to the ln of 16 over 2 t. Now notice I didn't convert this into decimals, because if I convert to the decimal, I'm going to start carrying round off error with me, which means I might not get the correct answer at the end. So that's why you want to leave it in exact values. Okay, so now we're going to plug in 3. So y is equal to 200 e to the ln of 16 over 2 times 3. Okay, do you want to calculate that, or we can go on to the next problem? Go on. All right. Oh, I do want to caution you. Let's calculate that, because I think that something important is going to come up. Calculate that for me. Let's do that. 200. Let's calculate this part. Okay. First of all, okay, find ln of 16, multiply by 3, divide by 2, and raise that. Take that in value, raise e to that power. E to the, what is that decimal? Tell me what that is. What is it? Huh? 4.158. Okay, and then raise e to the 4.158 multiplied by 200. Tell me what you have. Even? No decimal points? Really? What is it? Stop. I want decimals. 12,800. Is that decimal? Really? It turned out so nice and clean? Okay. Okay, so what is my decimal? Okay, 12, that's exactly what I want to hear. Okay, 12,000, go ahead. 0.7. Okay, now, this is going to happen to you on the AP test. We're talking about bacteria. We can't round bacteria up. Okay, you got to truncate that. So your correct answer is 12,788. Okay, do not round anything that is living up to the next whole number. Okay, cut it off. Okay. Okay, radium decomposes very actively. Half-life is 1800 years. Okay, T is equal to 1800 years. Find the decay constant. Okay, so they want you to find K. Then compute the amount of radium that you have in 100 years if you start with 2 grams. So C is equal to 2 grams. Okay, and then they want you to compute, okay, what happens when T is equal to 100 years. Okay, first we're going to use this information to figure out my decay constant. Okay, so it's going to be y is equal to EKC times EKT. C times EKT. So, half-life is 1800 years. What that is telling you is, if you have 2 grams, how many grams will you have left in 1800 years? If you start with 2 grams in 1800 years, how many? 1. Half of that. Okay, T is 1800. Okay. Alright, so 1/2 is equal to E to the 1800. Okay, so what are we going to do to both sides? Ln of 1/2 is equal to 1800 K, and my K is equal to ln of 1/2 over 1800. We're going to use that to find out how much we will have in 100 years. So it'll be y is equal to 2e to the ln of 1/2 over 1800, okay, times 100, because that's my t. Obviously, they don't cancel off. So y is equal to 2e to the ln of 1/2 over 18. Now, this is radioactive substance, okay? So you can have decimal values. You can round this one, okay? You can have decimal values. This is in terms of grams, so you have to put grams at the end, and you can't have decimal values. All right, 12. The city of California has 2,326 people in 1990. So 1990 population is 23,286. Okay, by 1998 the population was 28. So 1998 the population turned out to be 28753. Assuming the growth is exponential, find the growth constant. Estimate the population in 2007. So this is 2007. We want to find out what this is. This is just like the rabbit problem I did in the notes. Okay, first of all, how many years did it take to go from here to here? 8. Okay, in 8 years, it went from here to here. So we're going to use y is equal to CEKT. Okay, and we're going to find my k because I don't know what the rate of growth is. Okay, so we're going to put in 28753 is equal to 23286 e to the 8k, because I know that's what happens in 8 years. So this is 28753 divided by 23, okay, 286, and then what are we going to do? How should I bring that one down to the bottom? How do I bring that to the bottom? What do I do? ln. So I'm going to have ln of 8k. So my k therefore turns into, okay, 1/8 of ln of 28753 over 23286. Yes, sir. You want to leave that for right now as is, and then calculate the decimal. Yeah, at the end we're going to get this is population, so we'll have to cut it off. Okay, but leave everything in exact values until you figure this out. Okay, 1990 to 2007. How many years is that? How many? 17? Okay, 17 years. So we want to find out, this is y is equal to, okay, 23,286 e to the 1/8, okay, ln of 28,753 over 23286 times 17. So let's put 17 here. That will just make it easy for us. So times 17, so it'll be 17 over that. Okay. I'm assuming you can calculate that on your own, and make sure you truncate your answer. Don't round your answer up because we're talking about people. Alright, let's go to section 43. There's only 3 problems there. Emma, you leaving us? Nothing on section 43. We're good? Don't step on my wires. Okay. We're good? Then we'll move on to trig then. Or sequence and series. Alright, section 41. Questions on 41. We're skipping 42. So, section 41. Macy, what is it? 23? 23, huh? 18. Jasmine? 20? Okay, 20. Alright, let's start with 18. 18. Alright. You know what? This is one of the hardest problems out there. Only the smartest kids at Westview can do it, but everybody at Mount Carmel can do this problem. Alright. Look. This is telling you what to start with. What do you start with n? 0. So it would be 8 times negative 1/2 to the negative 1. Plus, what's the next number you're going to put in for n? 1. So 8 times negative 1/2 to the 0. Plus, what's the next number you're going to put in for n? 8. Okay, negative 1/2. And then when you put in 2, you're going to get 1. Next number is 3. 8 times negative 1/2. Okay, it's going to be 2. And then last number you're going to put in is 4. So you're going to get 8 times negative 1/2 to the third. You calculate each one of those and add them up. That's all you have to do. But what happens when this turns into like 4,000? You're not going to sit there and calculate 4,000 of these. So you like to have some idea what is going on. If you look, this formula right there, that looks like a sub n is equal to a sub 1 r to the n minus 1. That's a geometric sequence formula. My ratio is negative 1/2. My a sub 1 is 8. Okay? Or is it? Nope, it's not. It's not 8. Sorry. That. I gotta calculate that. My a sub 1 is this right here. It's this right there. Okay, that's going to be negative 2 times 16, which is negative 16. That's my a sub 1. Now, I can use my formula, sum of a geometric series, s sub n is equal to a sub 1 times 1 minus r to the n, all that over 1 minus r. So if this turns out to be 4,000, you just have to know what my ratio is and what is my first term. So you're going to put in negative 16 times 1 minus negative 1/2 to the 4,000. Okay? And all that over 1 minus negative 1/2. And then you can calculate up to 4,000 of those terms. Provided that your calculator can take negative 1/2 raise it to 4,000 power. I doubt it would. I don't think your graphing calculator can do that either. So you have to probably leave it right there. Right. Number 20. And then 23. Number 20. Let's see what we got. Number 20, you have a 3 minus 9 plus 27 minus dot, dot, dot. Alright. Now, they say dot, dot, dot. Got a problem here. If you're going to add out infinite number of terms, my ratio has to be less than what? 1. Okay? Take a number. Divide by the previous one. Negative 9 over 3. What's my ratio? Negative 3. Can I add up infinite number of these? Can't. If it was like negative 1/3, I can't. Now I can add a finite number of these. So if they tell me to add up the first 10 terms, then I can use the formula I just wrote. S sub n is equal to a sub 1 times 1 minus r to the n, all over 1 minus r. I can add a finite number of those. But I cannot add up infinite number of those if my ratio is bigger, the absolute value of that is bigger than 1. Okay? So that means, in this particular problem, it says if it exists, okay, it does not exist. But now, they want you to write this in sigma notation. That we can write this in sigma notation. Okay, my first term, my a sub 1 is 3. My ratio is negative 3. If I were to write this in a sigma notation, okay, it's going to look like, I'm going to use this formula, a sub 1 r to the n minus 1, and that's my a sub n. Okay, when I plug it in, I'm going to get 3 times negative 3 to the n minus 1. That's my formula. Okay, I'm going to write 3 times negative 3 to the n minus 1. My n. Okay, where do I start my n? At 1 or 0? Remember, it has to turn out to be the 3. So what should I put my n starting point? 1. And then infinity because I have dot, 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 dot. But I cannot find the sum.